Hi, in this video we are going to see about a Python IEEE project which is entitled as AI powered Android malware detection using machine learning, which is an enhancement of IEEE based paper title enhancing the sustainability of machine learning based malware detection techniques for Android applications, which is an IEEE 2025 journal paper. So before seeing the execution of the project, let me brief about this project. So all over the world, the smartphone users are increasing day by day, and most of the smartphone users are Android based. So when there is number of users or more, so the hackers or the cyber criminals will be targeting on the Android mobile application. So they will be launching different kinds of threats to attack. So one kind of threat is the malware. So in cybersecurity, to overcome this malware, the malware detection techniques are available. So in this base paper, the authors have used the machine learning based malware detection techniques for the Android applications. So in the base paper, they have developed a two-stage machine learning approach. So in the first stage, they first estimate the year of the app using the SDK version, and in the second stage they classify it as whether it is a benign or malicious through the weighted voting mechanism, which is applied to specific year malware detection model. So this is the method that they have used in this base paper. So you can see the details that is mentioned in the base paper, but kindly note that we are not going to do the same as mentioned in the base paper. So now let us see about our proposed system or model. So the first thing, we are going to implement this project using four different models. The first model that we are going to use is Logistic Regression, second one is ExtraTree Classifier, third one is Random Forest Classifier, and fourth one is Stacking Classifier. So using the Logistic Regression model, we have achieved the training accuracy of 93.88% and test accuracy of 94.17%. And using the ExtraTree Classifier, we have achieved the training accuracy of 97.19% and test accuracy of 97.42%. And coming to the Random Forest Classifier, we have achieved the train accuracy of 97.19% and test accuracy of 97.42%. And finally, in this, using the Stacking Classifier, we have achieved the train accuracy of 97.19% and test accuracy of 97.42%. So these are the models and the performance evaluation results that we have achieved. Now coming to the data set part, so we are going to use this data set, so which contains the data set records around 4,465 data set records you can see, and you can see the various features like access all download, access cache system, access check-in properties, course location. So there are various kinds of features available, and you can see the various data set records are available. So now let us see about our proposed system from the project abstract part. So here you can see the proposed project title, AI powered Android malware detection using machine learning, and this is the IEEE base paper title, and this is the IEEE base paper abstract. So coming to our proposed project abstract, so as mentioned, there are lots of threats and available and especially for the malware attacks. To overcome that, we have proposed this AI powered Android malware detection using machine learning, and we have developed this project using Python for backend processing, and we have used HTML and JavaScript for the front end, and for the web framework we have used Flask. Coming to the data set part, so we have used this Android data set, which contains around 4,465 dataset records, and attributes that is available is 242 attributes that is related to the permissions and the API behaviors. So we have implemented using four different machine learning models: Logistic Regression, ExtraTree Classifier, Random Forest Classifier, and the Stacking Classifier. And as mentioned, these are the accuracies that we have achieved using the model. So in the project we have used two different modes. The first one is manual detection mode. So manual detection mode is like the user will be entering the features, and based on the features it will be predicting whether it is an malware or benign. And another mode is APK file analysis mode, where the user can able to upload a APK file and the system will be scanning the API and extracts the features that is available in the APK, and based on the dangerous permission, suspicious API calls kinds of thing, we'll be finding a risk code, and based on the risk code we'll be classifying whether it is a malware, benign or suspicious kinds of thing. So these all the things that is mentioned in the proposed project abstract. Coming to the existing system, so we are going to consider the base paper as the existing one. So in the base paper they have developed the enhancing the sustainability of machine learning based malware detection technique for Android application, where they have proposed a two-stage machine learning model. So in the two-stage machine learning model, the first stage, the first system predicts the release year of the Android application based on the SDK features. So and that is the first stage. So using the second stage, they will be classifying the application whether it is benign or malicious, so based on applying the weighted voting mechanism across multiple year specific malware detection model. So this is the technique that they have used in the existing system. And the data set that they have used content Androzu repository, which covering the years from 2014 to 2023 kinds of things. So in the existing system they have compared with three approaches: retraining based classification, incremental learning based classifications, two-stage model classification. So these are all the things that is mentioned in the existing system of the project. Now coming to the disadvantages of the existing system. So main disadvantages of existing system are high computational complexity, dependence on SDK version information, increased model maintenance over time, concept drift challenges, limited feature adaptability, higher training time for long-term data sets, limited robustness against tampering and obfuscation. So these are the main disadvantages of the existing system, which explained detailedly with the subheadings of it. Next, coming to the proposed system, to overcome all these issues that is mentioned in the existing system, we have proposed the AI powered Android malware detection using machine learning. So here we have used Python as the code programming language, and we have used HTML, CSS and JavaScript for the front end, and Flask for the web design. So here the proposed system, we have applied multiple machine learning algorithms like Logistic, Regression, ExtraTree classifier, random forest classifier and stacking classifier. So each algorithm is being trained and tested with the dataset that contain 4,465 dataset records and has 242 features. So here we have two different modes, that is manual detection mode and the APK file analysis mode. So then finally we'll be evaluating our proposed system, and we'll be showing the metrics such as accuracy, precision, recall, F1 and prediction time of the models. So here the model of logistic regression achieved the training accuracy of 93.88% and test accuracy of 94.17%, and ExtraTree classifier, random forest classifier and stacking classifier, all these three models achieved the training accuracy of 97.19% and test accuracy of 97.42%. So the entire detection process is implemented in an interactive web application, allows users to select the detection mode whatever they have preferred, and they can able to see the results, and they can able to see the performance analysis of it. Next, coming to these all the things that is mentioned in the proposed system of the project. Now coming to the advantages of our proposed system. So the main advantages of our proposed system are dual detection modes of enhanced flexibility, high detection accuracy through multiple machine learning models, automated APK feature extraction, user-friendly web interface, graphical performance visualization, real-time prediction and scalability, improved security and early threat identification, efficient model comparison and performance tracking, integration of AI with cyber security. These are all the main advantages of our proposed system. Is somebody explain detail about the advantages of proposed system. Coming to the system architecture, this is the overall system architecture where we'll be providing you the input to environment data set, and we'll be making the pre-processing and feature selection, and the models such as logistic regression, ExtraTree classifier, random forest classifier, stacking classifiers applied, and we'll be using two modes, whether it is a manual feature based or APK file analysis, and then we'll be classifying and predicting it as whether it is a malware or benign, and finally we show the performance analysis and the graphs of it. These are all the system requirements. This is all the minimum hardware requirements for the project. The software requirement, this project can be executed in Windows 10 or 11. The coding language uses Python 3.12.0. Web framework is Flask. Frontend contains HTML, CSS and JavaScript. This is the IEEE base paper reference. So now let us see the execution of the project. So just go to the source code folder. Inside the source code folder we have this malware analysis and detection, and here we have the app.py file. So here in the command prompt type cmd and click enter. So the command prompt window open with the exact location of it. Now type python space app.py and click enter, and kindly wait for a few minutes. Now you can see this URL. Just copy this URL, go to any of your browser. I'm just going to Google Chrome and paste it, click enter. So now you can see the project home screen, a welcome screen with the project title AI powered Android malware detection using machine learning, and you can see the features that is mentioned: machine learning, custom training, performance analytic, real-time detection, permission analysis, detailed report kinds of thing, and accuracy ML model that we have used, and permission, threat monitor, technology stack that we have used. All these things are designed in the home page of the project. So first click the login menu. It will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and click the login button. So now you can see the login is successful. It will be navigated to the selection mode process where you can select the mode, which mode you wanted, whether a manual detection or the APK scanner. So you can see the features that is available in the manual detection. So like enter the app permission manual and predict whether it is using the trained model. All these details are being mentioned clearly for the in the user interface part. So first let us see the manual detection part. So just select the start manual detection. So now it will be navigated to the upload dataset part, so where you need to upload the dataset. So just select the choose file option. Now just inside the source code folder, we have this upload.csv file. Just select this upload.csv file and then click this upload dataset. So now after some time you can see it will be navigated to the dataset preview part where you can preview the dataset that is uploaded. You can see upload successful message, and you can see the dataset that is being uploaded. So now let us click the train model folder. So it shows that please wait, we process your dataset message, and after some time the training will be finished and it will be navigated to the prediction part of the project. So here you can see the AI powered Android malware detection using machine learning prediction part. So here first thing is you need to select the algorithm that you wanted. You can select whatever the algorithm or model which you wanted. So we have implemented 4 different ML models: logistic regression, ExtraTree classifier, random forest and stacking classifier. I'll show you all the 4 one by one. So first let me select the logistic regression. So here you need to enter the app features, whatever the thing that we have shown in the dataset part. So the important features that is available. So you can just use the test data folder and you can just select the features that is available in the test data folder, or you can use the train data set, whichever is available, and we have which is we train the system, or you can use this test data and we can see the predicted result for it. So now for the first case I'll just give the access network state yes, and read phone state as yes. Next let me select the receive boot completed and receive SMS. So for the first case I'll just give all these options that has been selected, that has been asked, and then click the analyze and predict. So now you can see the predicted result. It is a malware. So it is being detected as a malware. The model selected is logistic regression. You can see the confidence analysis, benign or malware. So it is a malware with 97.36%, and you can see the 4 active permissions and total scanned and what is the risk level. So you can see the permission analysis, whatever the permission analysis that is we have entered, it is been shown here. And you can see the security recommendation, that is critical warning, malware characteristics. So do not install this application or install immediately if already installed. Perform a comprehensive device security scan using updated antivirus software. Review and revoke any suspicious permission granted. Change passwords and monitor your device for unusual behavior. So these are all the some security recommendation that is provided for the malware detected case. So if you wanted to download this in a report format for the future reference, you can just select this download report. So it will be asking to save file. So I'll just save as PDF. I'll just save it in the desktop as Android 1. So now you can just open that and you can see the things, that is whatever that option that we have selected, and what is the predicted result for this is being rated as malware detector. So this can be used, the results are exported for the future reference, you can use it. So if you wanted to check with other case, you can just select new analysis. So it will be loading the prediction page again. So this time I'll just select the second model, that is ExtraTree classifier. For this time case, I'll just give access network state as yes, and read external storage as yes, and let me leave all other things and let me analyze and predict it. So now you can see for this case it has been predicted as a benign app, so which means it is not a malware, and the model that we have used is ExtraTree classifier. You can see the confidence analysis of it, and what is the active permission, total scan and permission analysis, what are the things that is available, say safe application authority. So similarly you can just download this report and save it as a PDF for future reference. So I'll just save it as Android 2. And you can just use it the data that we have used. So I'll just go for the new analysis again to predict with other case. So for this time I'll just select random forest algorithm, and I'll select access network state, and let me select the camera option, read external storage, read phone state, read SMS, receive boot completed, and receive SMS. So I'll select all these options now. So 7 options have been selected. Here you can see the options how much we have selected. Let us go to the analyze and predict. Now you can see it is predicted as a malware detected. The model that we have selected is random forest, and it is 100% malware of it. So now I'll just go to the new analysis. I'll just select the stacking classifier, and this time I'll just select the access Wi-Fi state as and then I'll just select access network state. So now let us predict for this case, and you can see it is a benign app. For the app model that is selected is stacking classifier. You can see the confidence analysis and other details that we have shown. So in this way you can just check with the all other cases that is available. So there are lots and lots of records available. You can check with the different scenarios by providing all those inputs and different models that is available. So you can show different kinds of results based on the data set that we have trained on the test data part. So now let us move to the next part, that is the performance analysis part. So just select the performance analysis. So now it will be loading the performance analysis dashboard. So here you can see the performance analysis for the 4 models: logistic regression, ExtraTree classifier, random forest, and the stacking classifier. So in the logistic regression you can see the test accuracy of 94.17%, precision with 94%, recall with 94%, F1 with 94%, training time 1.6 seconds, prediction time is 0.12 seconds. The ExtraTree classifier you can see test accuracy with 97.42%, precision with 97%, recall with 97%, F1 with 97%, training time with 2.3 seconds, and prediction time is 0.05 seconds. In random forest, the test accuracy is 97.42%, precision with 97%, recall with 97, F1 with 97, training time with 2.3 seconds, prediction time with 0.05 seconds. And stacking classifier, the test accuracy is 97.42%, precision with 97%, recall with 97, pre-F1 with 97%, training time with 8.4 seconds, and prediction time is 0.18 seconds. In dataset overview, the total samples that is available is 4,465 dataset records. Malware samples contain 3,565, and benign samples with 900, features with 23, and training split is 75 to 25. Training configuration with the oversampling, random state, random fit estimators, stacking meta model, cross validation. And performance summary, you can see the details, and here you can see the model performance comparison with the accuracy, precision, recall, F1 scores of the 4 models that we have shown. And here you can see the confusion matrix of all the models. So first model, that is logistic regression with the true and predicted label, ExtraTree classifier with the true and predicted label, random forest classifier with the true and predicted label, stacking classifier with the true and predicted label of the confusion matrix. So in this performance model performance dashboard, you can see the performance analysis of accuracy, precision, recall, and F1 scores of all the 4 models, and you can see the dataset overview and model comparison, and you can see the confusion matrix. And finally, let us see the chart part. So in the chart part, you can see the static charts that shows the malware versus benign distribution. So malware contains 3,565 dataset records and benign with 900 dataset records. And here you can see the model accuracy comparison, showing the comparison within the logistic regression, ExtraTree, random forest, and stacking classifier. And here you can see the precision versus recall comparison chart also for the 4 models, random forest, ExtraTree, and stacking classifier, and the logistic regression model. And now let me log out and go to the next mode, that is the APK scanner application. So here you can see the APK malware scanner. So where we first, let us load the APK file, select an APK file. So here we have given the APK testing folder for 3 cases: benign, malware, and the suspicious. So I'll just go for the benign case first, GPA calculator app, and let us analyze the APK. So now you can see it is a safe application. So this APK is a safe application which shows the risk score of 25 out of 100, and you can see the package name, permission, suspicious API, and file size, and you can see the file hash using SHA-256, and you can see the dangerous permissions that has been shown, and you can see the suspicious API calls that is being shown in this APK. So now I'll just click this upload option. I'll just select the another one from the malware as APK Puri. I'll just select this APK and select analyze APK. So it takes some time to scan. Based on the file size, the time will be varied. Now you can see it has predicted this as a malware. So high risk, do not install, and you can see the risk score is 100 out of 100. So here the risk score is calculated and shown based on the permissions only. So this is an this is a model only. This is not a complete real-time application. So this is a prototype. So based on the permission of the app, it is predicting or classifying it as a malware detector. So here you can see the risk score and permission, suspicious AP, and file size, and you can see the file hash and what is the suspicious indicators. What are the suspicious indicators that is based on this APK is being shown, and dangerous permissions of this, and you can see the suspicious API calls for it. Now I'll just select another APK. So I'll just select this base.apk and let us analyze it. So now you can see it is classified as the suspicious application. So it is the suspicious one. So shows a score of 35 out of 100. And you can see the permission, suspicious API, file hash of it, and dangerous permission that is available, suspicious API call that has been classified. So in the detection mode, you can just select the manual or the APK scanner according to the mode that is selected. You can just give it, and then we can see the performance analysis of the model, and we have shown the chart part of it. So now let me log out. So before completion, let us see the frequently asked question for this project. So the first question is, what is the main objective of this project? So the main objective of this project is to detect the malwares in the Android mobile application. So this is to enhance the mobile security based on the machine learning model. Next question, why is malware detection important for Android application? So we all know Android is the most widely used mobile operating system. So it has lots of threats. So one of the threat is the malware. So malware can able to compromise the user data, steal the personal information, and harm the device performance. So detecting the malware early helps the user to protect their user privacy and secure their sensitive data and maintain the system integrity kinds of thing. Next question, what dataset is used in this project? So in this project we have used two Android dataset which contains 4465 dataset records and 242 attributes. So these dataset features represents the API permissions, app permissions, API access and behavior characters kinds of things, so that it can be distinguished as a malware or benign. Next question, which machine learning algorithms are implemented in this project? So in this project we have implemented using Logistic, Regression, ExtraTree classifier, random forest classifier and stacking classifier. Next question, which algorithm achieved the best accuracy? So in this project, as we have used 4 different algorithms or model, but 3 different algorithms or model achieved the same highest performance of 97.19 test accuracy. So stacking classifier, random forest classifier, ExtraTree classifier, all 3 achieved the best accuracy. Next question, what are the technologies used in this project? So backend we have used Python, frontend with HTML, CSS, JavaScript, web framework with Flask, and environment with Jupyter Notebook or VS Code. Next question, what are the 2 modes of detection in this system? So the 2 modes are manual detection mode and APK file analysis. Next question, how does the system classify an APK file as a malware? So when a user uploads the APK file, the system backend extracts the relevant permissions based on the API related features from the file. So it extracts the API contents and checks for the dangerous permissions, suspicious API calls, malware signatures, multiple DEX files and native libraries. So based on this, it will be calculating the cumulative risk score. So based on this risk score, APK has been classified into benign, suspicious or malware. Next question, what performance metrics are used to evaluate in our proposed system? We have used accuracy, precision, recall, F1 and prediction time. Next question, how accurate is the system overall? So the proposed system achieved around 97.5% of test accuracy. Next question, why is Flask used in this project? So Flask is a lightweight Python web framework, so that it efficiently integrates the machine learning backend with the web front end part, so that the user can easily able to select the modes and they can able to identify the application whether it's a malware or not. Next question, what type of analysis does the project perform, whether it is a static or dynamic? So in the current system we are doing static analysis only. In the future part we can able to extend it as a dynamic analysis. Next question, what are the advantages of using machine learning for malware detection? So main advantages are ability to detect both known and unknown malware, reduced reliance on traditional signature database, improved accuracy and adaptability over time, automation of the malware detection process, scalability and integration with web-based security platform. Next question, what is the real world application of this project? So the real world application that can be integrated into the mobile security platform, antivirus tool or app store verifications kinds of thing. So this can be used in the real world application. Final question, what differentiates this project from the traditional antivirus system? So in the traditional antivirus system, that antivirus depends on the signature, fixed signatures. So based on the signature, it will be predicting whether it is a malware or not. So here in this project, we are using machine learning model to identify the behavior pattern. So this allows to detect both known and unknown threats. So based on the, it will be offering an adaptive data driven approach to the malware detection. So these are all the frequently asked question for this project. So this is all about the project AI powered Android malware detection using machine learning, and thank you for watching.